3 electron volt. And for red light to be emitted, this should be 700. If you calculate it, it will be almost 1.8 electron volt. 8 electron volt. Okay. So this band gap, minimum band gap Eg should be 1.8 electron volt for emission of red light and 3 electron volt for violet light. So band gap should be in the range 1.8 electron volt, yes, 1.8 electron volt to 3 electron volt. This range, band gap should be in this range. Okay, then volt, the 1.8 volt to 3 volt, 1.8 volt to 3 volt, this band gap. Okay, so any type of material will not act at LED. Okay, what type of material will be effective as for use of LED, whose minimum band gap is 1.8 volt. Okay, minimum band gap may be higher, but minimum band gap should be 1, and in that case red light will be emitted, and if it is up to 3 electron volt, then violet light can be emitted. Okay, and say yellow light in the intermediate band gap, intermediate will be there. And how this type of material can be prepared? Normal diode cannot act as LEDs because their band gaps are not that much that way. That an electron should come direct to hole. Electron should recombine with hole in a direct manner. In normal diodes, they cannot straight falls to holes. There are some intermediate stages. So normal, the energy emitted, there is heat energy or infrared, some type of infrared energy, infrared radiation, heat radiation. They are not in visible range. So they cannot act as light emitting diodes. What type of diodes are necessary? What type of materials? Yes. You see, here some special purpose diodes, specially prepared diodes, they are called LED. It is called 3,5 materials. So 3,5 means group 3 and group 5 in periodic table. Okay. Gallium arsenide. It is not silicon. Normal germanium cannot act as LEDs. Okay. It is a gallium arsenide. Gallium 3 volt, 3 in the periodic table in the group 3 element and arsenic group 5 element. Gallium arsenide, indium arsenide, indium phosphide, they can act as LEDs. They satisfy the purpose of LEDs. Or amorphous silicon, crystalline silicon will not be LED, will not function as LED. Amorphous silicon can act. In that case, these type of materials are called direct bandgap materials. Direct bandgap means yes, their conduction band and valence bands are not, that's parallel type. This type of things and this type of thing. This is valence band and this is conduction band. And here they just, if you plot momentum versus energy of the electrons, energy, and this will be the graphs, and you will see that from here electron from here can directly form from electron here, electron to here, and recombination occurs. If this gap, when it is greater than 1.8 electron volt or 3 electron volt, then emission of visible light occurs. It is called direct band gap semiconductors. So for LED, any type of semiconductors will not do. It will be that they should be direct band gap semiconductors. If the band gap is not direct, say curve is that way, then from this to that no fall will be there. There are some intermediate stages, and that loss, due to that stage recombination, no visible light will be emitted. So there should be direct band gap semiconductors. So for LED, what is required? Direct is 3,5 materials: gallium arsenide, indium phosphide, amorphous silicon, all these things. This should be direct band gap semiconductors in momentum energy diagram, and minimum band gap should be 1.8 electron volt to 3 electron volt for entire visible spectrum to be emitted. Okay, and this is a symbol for a light emitting diodes. Yes, this normal diode and this light emitting diodes. Okay, And what are the special features? Yes, heavily doped recombinant should be heavily doped. It should be forward biased. Radiative recombination, yes, the recombination should be radiative. Radiative is visible light radiative. There are infrared LEDs also there. Radiative. Excess minority carriers should be there near the junction. Okay. So that recombination occurs. Or HDU should be EG should be greater than HE. EG should be greater than HE. What we have told you. You see, and if you plot a graph here, you will see that normally when you increase light, increase the voltage, yes, current, increase the current to the diode, the radiation, light intensity increases as a linear fashion, straight line fashion. Current increases to the light increases up to a certain stage. Then increase of current will not increase the light. The intensity of light diminishes. Intensity of light diminishes. And this is the nature. This is the variation of light intensity with current. Okay. Now these things. So minimum band gap should be 1.8 electron volt for visible light. For infrared LEDs, it should be 1.4 electron volt. This type infrared LED. Okay. Intensity increases with forward bias. Okay. Up to a maximum value. EG should be greater than 1.8 electron volt or should be greater than 3 electron volt. Okay.